Hello and welcome to today's video where we're going to be manually calculating the time of sunrise or sunset using the free Nautical Almanac that is available from the nauticalalmanac.com. What you want to do is download yourselves a copy of the Nautical Almanac 2018, which is available from the nauticalalmanac.com. Now, this almanac is absolutely brilliant for learning the techniques of celestial navigation, but I would not advise using it where safety depends on it. I'd always get the official version available from either the Admiralty or the US Navy. Once you've got yourselves a copy, we're going to head across to pages 70 and 71 for today's example. Now, these are the daily pages covering April 13th, 14th and 15th. Page 70 is the left-hand page, and that details planets and stars, as well as Aries, but we're interested in the right-hand page, page 71, which has the details for the Sun and the Moon. Now, it's got the positions of the Sun and the Moon on each of the 3 days on the left-hand side of this page, and on the right-hand side you can see there's tables for twilight, sunrise, sunset, as well as moonrise and moonsets. So let's have a look a bit more in detail at the sunrise-sunset table. First thing to note on this table is it spans across all 3 days. There's not a different table for each individual day. You've got sunrise column down here, and before that you've got the civil and nautical twilights, and then on the right hand side of the table you've got the sunset column, and again the civil and nautical twilights that occur around sunset. Now, we're obviously interested in the sunrise times for our example, but you can follow the exact same principles to work out either the twilights or sunset. Now, for our example, we're going to be looking at New York in the USA on the 14th of April 2018. We already know that the 14th falls within the date range on these pages, so it's this table that we're going to use. Firstly, we need to know the location of New York, and I know the coordinates are 40 degrees 43.9 north and 073 degrees 56.1 minutes west, and then we're also going to want the time zone, which in New York is UTC-5, but they do operate daylight saving time, bringing them to UTC-4 in the summer. Given the date of the 14th of April, we know we're going to need UTC-4. Now, wherever you're working out sunrise or sunset, all you need is your coordinates and the time zone, and time zone is just to be able to convert into local time. You can always leave it in UTC if you'd prefer. Step 1. We want to find the universal time of sunrise at our particular latitude. So, we know the latitude of New York, we've already said, is 40 degrees 43.9, but we can't read that directly from the table. 43.9 fits somewhere between 40 and 45 degrees north. We need to interpolate to find our exact time of sunrise. To do that, we want to write down the times either side. So at 45 degrees the sun rises at 5:17 in the morning, and at 40 degrees the sun rises at 5:24 in the morning. Now, there's lots of different ways you can interpolate. My preferred method is working out how far you would travel, so the change in latitude, for every 1 minute change in sunrise time. The reason I do this is because we want to round to the nearest minute anyway, so there's no point in being more accurate than that. Firstly, you want to look at the difference in your latitude. So from 45 to 40 degrees is a 5-degree change in latitude. You can see that as the latitude changes from the equator, they're doing 10-degree jumps, then it's 5-degree jumps, and then right the way up in the northern latitude we're down to 2-degree jumps. So it's not always going to be 5, it's just in these middle latitudes here it will be a 5-degree change in latitude. Then we want the change in time. So from 5:17 to 5:24 is a 7-minute change in time. And all we can do is just divide those by each other to find out that we change 0.71 degrees, which is 42.6 minutes of latitude. That would be the change for every 1 minute difference in sunrise time. So for every 42.6 minutes latitude change, sunrise time is going to change by 1 minute. I don't really mind which way you interpolate. This is the way that I prefer, so this is the way I'm going to show you in this example. So let's just tidy this all up. So with some clear space we can work out the exact time of sunrise at our particular latitude, and now our latitude is going to be near to 40 degrees. We're actually 40 degrees 43.9, and given that difference we can see it's going to be a 1 minute change in sunrise time. We can look at which way it's changing. So 45 degrees, the sun is rising earlier than it does at 40 degrees. So we're moving that way, so it's going to be 1 minute earlier than it is at 40 degrees. So at 40, 43.9, the sun is going to rise at 5:23. But that's not the whole story. We need to move on to step 2, which is to find the true time difference from the prime meridian. I think I can explain this with a picture a little bit better. What we've actually found out is the time of sunrise on this latitude is going to be the same time regardless of where you are in the world, but it's only going to be at that precise time on the Greenwich meridian. To find out the exact time at your particular longitude, you've got to work out the time difference celestially from the Greenwich meridian. This is what I mean by finding the true time difference. Things are going to happen later the further west you are. To find out exactly how much later, let's think of the world as a whole. It spins a full 360 degrees in 24 hours. And divide that down by 24 to find that the Earth spins 15 degrees every hour. For our particular true time difference, we want to work out how long it's taken the Earth to spin 73 degrees 56.1 minutes. All we do is we take that longitude and divide it by 15 degrees to find 4.929 hours, which in real terms is 4 hours 56 minutes. We know that our true time difference between things happening celestially in Greenwich to things happening at our longitude is 4 hours 56 minutes later because it's west. Next we want to find the universal time of sunrise at our destination. Now this is applying that time difference to the UTC time that we've read out of the almanac. So all we do is take our position, and we know that sun rises on our particular latitude at 5:23 in Greenwich, but it's going to rise 4 hours 56 minutes later on our longitude. Because we're at 73 degrees, we're not at 0 degrees. All we do is we add these two together to find out that in New York the sun will rise at 10:19 universal time. The final step will then be to convert that time into local time, and this is where we use the time zone that we're currently operating on. So the time zone in New York on the 14th of April is going to be UTC -4. So we've got to take the universal time and subtract 4 hours from it to convert into local time. This gives us our local time of sunrise at 6:19 in the morning. Now I can compare this myself to timeanddate.com, which gives us the sunrise time on the 14th of April at 6:18 in the morning, and that difference in 1 minute is actually pretty insignificant and is explained by the fact that these daily pages cover April 13th, 14th and 15th. There's been a bit of rounding here in the almanac itself, so we know that our time of sunrise is actually correct. And that brings us to the end of this video. You can just follow all 4 steps, take a note of these, and you'll be able to use the almanac to calculate sunrise and sunset wherever you are in the world. Hopefully you found the information in this video interesting and useful. If you have, a thumbs up is always appreciated. If you've got any questions, leave them in the comments below, and to keep up to date with all videos that I publish, make sure you hit that subscribe button. Until next time, thank you for watching, and goodbye.